In these set of paired videos, we're going to take a look at how to do the prelabB calculations for the second question in the prelabB. I'm hoping that you'll find that the discussion in these two videos will help you not only to do the prelabB, but also to actually do the calculations in labB itself. I have an example problem here shown on my screen. This problem is not part of your data pool, but you'll see that your data pool, your set of questions, are very similar to this. I'll be using Microsoft Excel, both the desktop version as well as we'll look at the online version because there are some minor differences in terms of how you apply the calculations. So let's take a look at the problem. You can see that a student has measured the mass of several cubic pieces of a metal alloy. She has determined that the volume of each of these pieces is 5.00 centimeters cubed, or 5.00 mils. Using a top-loading balance, she found the masses of each of these pieces of metal alloy. And then we need to answer these particular questions. One thing to pay attention to is you're asked to find the mean or the average density. So not the average mass of these things, but rather the average density. So I'd like to do the density calculation first. And to do this, I've set up a little table here. And this is something that I encourage you to do when you're doing, well, one, the calculation for the prelab, but secondly, also the calculations for your actual lab. And so just set up these little tables where you can input the data and then do the corresponding calculation. While a lot of the calculations, of course, can be done on a calculator, I think you'll find it far more efficient to do the majority of the basic calculations, not even the ones where you put the formula in, but just the subtractions, the divisions, and such. Do that in Excel. One of the things that you may be wondering is why didn't I just take the average mass and then divide that by 5? Well, one of the reasons is later on I'm going to be looking for an outlier, and I find it easier to be looking for an outlier in terms of density rather than comparing the masses. Okay, so to do this first calculation, I want to divide the number 14.23 by 5. So I'm going to click inside the cell here for density. I'm going to click equals, and at this stage I can input a formula. Now I also want to point out to you that when we type the symbol equals in the desktop version of Excel, there's a little window that pops up here that is prompting me if I wish to put in a formula. You'll see a little bit later that this is not included in the online version of Excel. Okay, that's often caused some confusion for students. So anyways, what we want to do is take this number right here, the 14.23, and I clicked on it, and so that's in cell D4, and then the forward slash, meaning divide, by the 5, and then we'll click enter, and then we get this value of 2.85. Now note, this is to the correct number of sig figs. Sometimes your Excel will be set up so that, for instance, it's not showing any decimal places and such. So what you can do is generally right-click on the cell, and then you would format cells. And we'll just wait for the window to pop up. And then you can see here that I have selected here 2 decimal places. And so if we needed 3 decimal places or 4 decimal places for the correct number of sig figs, you would need to do that. So now I click OK. All right, now I want to repeat this calculation. This is the beauty of Excel. Note that I'm putting my mouse on top of the bottom right-hand corner. I see a plus sign here. And now I'm going to left-click, hold down, and drag. And now the calculation will be applied to all of those values. Okay, so now that that calculation is done, I want to calculate the mean. And so to do this, I'm going to apply a formula. So once again, I'm going to select this cell where I want the calculation to be done. And then I'm going to click equals. And then once again over here, I see that I'm prompted to put some sort of function. And the function that I would like to put in here is to take an average. So I'm going to click on this. average. And it's going to ask me, well, which values do you want to take an average for? And so if I, for instance, click in here and then select these values and then enter, yep, so those are the values that I want, and then click OK. So an average value has been taken, and that's 2.91. Now I'm going to grab a version of Excel, the same sort of problems, but this is the online version, and many of you will be working from here. Let's just quickly get to the same place that we were with the other Excel sheet. So right in here, I'm going to do a calculation. Once again, I'm going to type in equals. Note that no formula prompt has come up here, but I can still apply an equation. So it'll be 14.23. I'm going to select the D4 cell, /, and then divide by the 5, enter. Calculation's been done, correct number of sig figs. I'm now going to drag. The rest of the calculations will be done. And now I want to calculate the mean. So if I do apply an equals here, again, I'm not prompted for some formula. So I'm not going to, in this case, do that in that way, because I'm not going to type in an actual formula to calculate the average. But rather what I can do is click on this function button. So I've selected the cell where I want the calculation to be done. I click on the function button, and now I want to take an average. Next. Where do I want to take the average? Well, I'm going to select the appropriate part on the chart. And so you can just come over here and drag. And now I have selected the appropriate values. I click Insert, and then Enter, and then the average is taken. So you can see it's very similar. The difference is you need to click on this function button. So I'm going to move the online version of Excel. Now let's come back to our sheet right here, and let's now apply a standard deviation calculation. Because once again, if we look back to the problem here, we want to calculate the mean density, and then we want to calculate the standard deviation. So I select the cell where I want the calculation to be done. I can type in equals, and then I'm prompted with this cell here at the top, function cell, to choose, let's say, the standard deviation. So I can do this. And by the way, if you're given a choice of different standard deviations, you want the standard deviation .s versus .p. The .s is the sample standard deviation, and that's the best kind of standard deviation to take when you have a small set of values that represent a larger population. So it's a sample from a population. So I could do that, but note that the desktop version of Excel also has this function button. So I equally can click that and then also look for standard deviation .s, click OK. So there's two ways to do this, right? Now I'm going to be selecting the values for which I want to take the standard deviation, which is these values again. Click Enter, click OK. The standard deviation has now been taken. Okay, so I've essentially answered the first two questions, but I do want to point out to you that while I won't see your work in Excel, and so I don't really care what you do in Excel, I want you to be aware, as according to the outline in our lab manual, the standard deviation, or the absolute error associated with a mean, always only has one significant figure. So yes, we have all these other digits, but technically this should be rounded to 0.06. Now, just to show you then, if I was reporting this value in my lab, that is the mean plus the standard deviation, I would do it in the following fashion. I'm going to come over here, and I'm just going to remove this little box so you can see. So 2.91 plus or minus, and then I wrote a portion of the full standard deviation. If you wrote that, you would get lots of points off because this is not correct. What you want to do is take that standard deviation and round to one significant figure. So now this is reported as 2.91 plus or minus 0.06. One last comment. the decimal position of the standard deviation must match the decimal position of the last number in your mean. Now, in this case, they do. Because remember that we're writing this to the correct number of sig figs. So this is 2.91. So we're certain about the 2, we're certain about the 9. We're guessing at that 1. By how much are we guessing? By 0.06. Now, if this 0.06 had actually been, let's say, 0.2, okay, not 0.06, but 0.2, we would have had to round the mean to 2.9. Again, the decimal place of your standard deviation has to match the decimal place and the last number in your mean. Okay, so let's go back now. So when I'm typing in the answers here into my problem set, I would type 2.91, then I would type 0.06. Note that these prelabB quizzes are formatted to look for the correct number of significant figures. And now both the mean and the standard deviation are reported to the correct number of significant figures. This would now be a good time to take a pause in the first part of the two-part video series. In the second part of this video, we'll take a look at how to calculate the percent difference, which gives us a sense of the accuracy. And we'll also take a look at what happens to the precision and accuracy when the outlier value is taken away.